Today we're going to be working on astrophysics. Well, first of all, what is astrophysics? Astrophysics is physics with space. So like orbits, that kind of stuff. So we worked on gravity in our last couple videos. And if you weren't here, I think you already know gravity pulls stuff down. But the formula for gravity is gravitational force is equal to g-force times mass 1 times mass 2 divided by the radius. If you weren't here, so here let's do some problems with gravity to start off with. I'm gonna grab a pencil. So let's say we have a planet orbiting around its star, and the radius is going to be 50 million miles. Just to give you a hint what that feels like, we are 91.3, I think, million miles away from the sun. And let's see, this planet is 8 sectillion kilograms. A sectillion is 1 with 24 zeros. And let's say its star is 200 sectillion. Kilograms. And let's say the g-force is going to be equal to 30. So I want you guys to figure this out on your own while I figure it out. So I got 600 septillion. I don't know what you got, but I think that's correct. So now we're going to be working on centripetal and centrifugal force. Well, what is centripetal and centrifugal force? So centripetal force is a force that pushes down on an object in motion. And centrifugal force is a force that pushes up on something in orbit. So have you ever like swung a ball around on a rope like this? If you could, well, if you have, could you feel the force that kind of pushes the ball away from you? That's the centrifugal force. So, and mm-hmm. So, if I can find my pages. So, 1 second. So, here I wrote some centripetal and centrifugal force. And so, centripetal force, where I put my pencil. So, centripetal force is equal to the mass times the velocity squared divided by the radius. And this is centripetal force, so that's the force pushing down. And centrifugal force is equal to mass times angular speed, which is a W squared, times radius. So here are our two formulas. Let's do an equation. Let's draw a ball. Let's draw 1 kilogram ball on a rope. And so let's say its angular speed is going to be 5 meters per second. And the radius is going to be 7 feet. So 1 kilogram. And let's say its normal velocity is 2 meters per second. So here is our little example, bottom. Now let's do some equations for it. So centrifugal force is going to be mass, so 1 times 5 times 7, which is equal to 35. So centrifugal force is 35. And I think it's measured in newtons. I may be wrong, but I think it's measured in newtons. So now let's work on the centripetal force. So we have mass, which is 1 times velocity squared, and that's going to be 4 divided by the radius, which is 7, and what's 4 divided by 7? Alexa, what is 4 divided by 7?
4 divided by 7 is approximately 0.5714.
Okay, yeah, I would never have got that. I'm sure we'll round it up to 0.57. So the centrifugal force was way more than the centripetal force here. It was more by a factor of 34 point 34.43. So that's a lot. Let's do some more equations. So let's have a 1 kilogram ball with a radius of, let's do a planet this time, so 5 sectillion kilograms. So 5 sectillion kilograms. And so 5 sectillion kilograms, angular speed is going to be 450 meters per second, and the real speed is going to be 500 meters dash seconds. So, and the radius is going to be 100 septillion, no, 100 million, I meant, miles. So that's our equation here for centrifugal force. Centrifugal force is equal to mass times so we have our mass, which is 5 sectillion times angular speed squared, which is 450 is Alexa, what is 450 squared?
450 squared is 202,500.
2,200. 2,002. And our radius which is equal to 100 million. Equal to mm, around the 202,500 up to 200,000, and I got 100 million sectillion. This must be a lot of zeros there. So that's the centrifugal force, and now the centripetal force. So centripetal force is equal to force. Well, centripetal force is equal to mass times velocity squared divided by 3. So here we have the mass, which is going to be 5 times 2,000 So 50 times 50 at 2 0. 2,500. 2,500,000. 2,500,000. So now we have that time divided by radius, which is 100 million. So this is going to be equal to, so the bottom, so the second part of this equation is equal to 2.5. And that would mean that this is equal to 12.25, no, 12.5 sectillion. So our centrifugal force is definitely way bigger than the centripetal force. That's going to be it for today. Bye, and thank you for watching.